Video, we're going to look at a couple more basic examples of manipulating trigonometric identities, verifying trigonometric identities utilizing the sum and difference formulas. The first thing we're going to go ahead and identify first is the fact that in the previous videos or previous classes, we've verified that the sum and difference identity for tangent are now applicable. So we're not going to revert back to these when we see tangent like we did previously. We're going to go ahead and straight up use these ones. You'll notice this particular identity, tangent of x plus pi equals tangent of x, is not a ready and straightforward identity on this sheet, so we don't have to use previous identities to prove it. I can simply use this identity right here because it's the sum of a tangent against the sum on the inside of a tangent. So I'm going to go ahead and manipulate the side that has more complex interiors. That's, again, the main step for these. I'm going to go ahead and transfer this side right here into being this down here. So the first thing is going to be the tangent of x plus the tangent of pi divided by 1 minus the tangent of x times the tangent of pi. This is all supposed to end up equaling to tangent in the grand scheme of the problem. So at this point, I should be able to simplify some of this information. Tangent of pi, for instance, should be something that I can identify or evaluate clearly. We'll notice that the tangent of pi on the unit circle sits over here, and that value is going to be a value of -1 comma 0. We know that tangent is sine over cosine, so it's going to be 0 over -1. So the tangent of pi is going to end up being 0. So I have the tangent of x plus 0 divided by 1 minus the tangent of x times 0. But anything times 0 should end up being 0. That leaves me with just simply the tangent of x divided by 1, which is the same thing there. Again, this is how you can apply these identities such a way that they can simplify what we're given so that both sides are equal. Notice how in most of the previous examples I have been working with specific one side steps. You don't have to do all of the cases this way, but in most examples, it's how things work out. So the tangent of x minus pi over 4, verifying it equaling to the tangent of x minus 1 divided by the tangent of x plus 1. So now again, you might want to try working with this side, but keep in mind that we're not going to touch this side until I get this side to have, again, singular interior values. So the first step that I'm going to do is I'm going to manipulate this side using the difference identity for tangent. That difference identity looks like this right here. And then I'm going to go ahead and see what I can do about simplifying. So the first step is I'm going to have the tangent of x minus the tangent of my y being pi over 4, divided by 1 plus the tangent of x times the tangent of my y, again, my y being pi over 4. This is supposed to be equal to this side over here, and hopefully that's what it's going to simplify down to. So if I do this very carefully, tangent of pi over 4 sits here, and I know that that's going to be radical 2 over 2, divided kind of radical 2 over 2. With sine over cosine, it's simply going to be a value of 1. So the tangent of pi over 4 is 1. So if I continue to simplify this side, I'm going to get tangent of x minus 1 divided by 1 plus the tangent of x times 1. Now, you might be able to stop here and say, hey, guess what? That's the same thing as this one, and I'm done. That is only one minor step away from getting there. Again, I can swap the tangent of x with the 1, and I do have the exact same thing. And that's how, again, you utilize the sum and difference identity for tangent in terms of verifying more identities.